In question 4a, we need to state what is meant by the wave-particle duality of electrons. Well, electrons have some wave-like properties and some particle-like properties. In B part 1, we have electrons with a wavelength of 1.2 times 10 to the minus 10 meters that are used to investigate the spacing between planes of atoms in a crystal. We need to calculate the momentum of these electrons in an appropriate unit. Well, for this we can use the wavelength lambda is equal to the Planck constant h over the momentum. And so we can rearrange, putting in the values given on the formula sheet and in the question, gives a momentum of 5.5 times 10 to the minus 24 kilogram meters per second. In part 2, we need to calculate the speed of the electron. Well, momentum is equal to mass times velocity, which we can rearrange, putting in the values, the momentum from the previous question and the mass of the electron from the formula sheet, gives a speed of 6.1 times 10 to the 6 meters per second. In part 3, we're asked to calculate the kinetic energy of the electron. Kinetic energy is half mass times speed squared, so putting in the values gives a kinetic energy of 1.68 times 10 to the minus 17 joules.